Good morning. My name is Lawrence Mobes, and I'm an editor here at Manufacturing Engineering Magazine. I'd like to first welcome everyone to another edition of the SME Media webinar. So welcome. We're glad that you're here. Our topic today is a new flame-retardant material, which is both halogen-free and 60% reusable. Today's presentation is sponsored by HP Additive and Endeavor 3D. HP Additive is part of the HP Development Company, a leader in providing personal computers, printers, and related services, which was formally established more than 80 years ago. And Endeavor 3D is a Douglasville, Georgia-based provider of additive manufacturing solutions, specializing in product design, production, post-processing, and quality assurance. Our presenters today are Stephen Korzik and Daniel Baker. Stephen Korzik is an additive manufacturing engineer at HP with a track record of spearheading multi-billion-dollar innovations in 3D automation and industrial process optimization. He has led million-dollar innovations in 3D printing, automation, and industrial process automation, large-scale facility upgrades, expanding the adoption of advanced manufacturing technologies, and implementing cutting-edge solutions that drive efficiency and scalability across global operations. And Daniel Baker is an application engineer at Endeavor 3D, managing the workflow from part identification to production. He plays a key role in the early sales cycle, guiding customers through application discovery, design for AM, and volume production preparation. With 8+ years in additive manufacturing, Daniel brings expertise in DLS, SLA, binder jetting, multi-jet fusion, and FDM. Before I turn things over to our presenters, I'd like to outline how the webinar will proceed. On the right side of the screen, you'll see a question and answer box. If at any time during the presentation you'd like to ask a question, please type it into this box and send it along. These questions will be answered at the end of the presentation. Should you experience any difficulty during the webinar, such as a blank screen or a lack of sound, please use the Q&A box to alert us, and we will respond individually in writing with a suggested fix. Also, this presentation is being recorded and will be available to view later today. You may then watch the recorded version of this webinar at a time in a place when you have more bandwidth. You may also watch the webinar as many times as you wish to catch details you might have missed or for any other reason. All you need to do is sign in again using the same credentials you used to join us now. And if you wish, you may share these credentials with colleagues who might benefit from learning more about this topic. Now, if everyone's ready, I'd like to turn the microphone over to Stephen and Daniel. Stephen and Daniel, the stage is yours.
Fantastic. Thank you so much for the introduction. As we mentioned today, we're going to be discussing HP's PA12 flame retardant material. We're going to discuss the blue card, the properties, and then review some real-world examples and leave some time for Q&A. Before we get started and jump right into the background of what PA12 flame retardant is, we'd like to start with a poll. So if everybody on the call would be willing to fill this out, we can gauge some interest and some familiarity with how familiar the crowd is with the flame retardant materials. I'll leave this on the screen for just a moment. Getting a few responses. All right. Okay, we've gotten a good amount of responses in. So the results of that poll are we have some familiar, somewhat familiar, and very familiar. So it sounds like this is going to be a very informative presentation for the group here that's today. So a high-level overview of the flame retardant material that's been enabled by Evonik is this is a halogen-free material that is certified as UL94 V0 at 2.5 millimeters. And we do have a blue card available that I'll show on the next slide. This material does have homogeneous flammability. So the flame retardant is actually encapsulated by the polymer. Why is that important? It allows us to have a reusability ratio. And we just recently improved the reusability ratio from 50% to 60%. This gives us a disruptive cost per part, it reduces the environmental impact, and like all HP materials, is manufactured with renewable energy sources. as part of HP's drive to improve the total cost of ownership, that 10% improvement in reusability ratio results in a nearly 20% reduction in final part for the customer. In addition to the flame retardant and the reusability ratio, we have premium part quality. It gives us a smooth surface, we're able to print fine details, and this has the same isotropic mechanical properties and dimensional accuracy you have come to expect from the multi-jet fusion platform. The FR material is available on the 5600 series printers using the D800 agents. As I mentioned before, just being a flame retardant material is not enough. We need to have a certificate of compliance to prove that. And we're happy to say that this material has been certified by UL at the UL 94 through the UL 94 process as V0 at 2.5 millimeters. For those eagle-eyed viewers, you'll see that this is down at the bottom saying that it's approved for use with reclaimed powder up to 50%. As I mentioned before, this is going to be re-established with 60% reuse ratio. Beyond the blue card, there are several other flammability properties that this has passed. We have, as I said, the UL 94 at V0 at 2.5 millimeters. It's also V2 at 1.8 millimeters and HB at 1 millimeter. We also have UL 746 results and A and B. There are some reports that are not shown here. If you do have questions beyond the flammability properties that are shown, please reach out to your application engineer for further discussion and further reporting. For some of those industry-specific flammability requirements, we do have testing available for railway and aerospace certifications. The key one that has been a recurring ask is R26, which is also at 2.5 millimeters. Flammability properties are not the only thing that matter, though, when we're talking about 3D printed parts. We also need to evaluate the mechanical and dimensional properties. The mechanical properties shown, again, reflect that isotropic property that we mentioned before, with a tensile strength of 46 MPa in both the X, Y, and Z directions. And then the dimensional properties can be expected to be the same as HP's PA12 material printed in the balanced print mode on the 5600 3D printer. In addition to the mechanical and dimensional properties, we have very improved surface roughness compared to the regular PA12 material. In fact, the surface roughness is similar to the PA12 smooth material enabled by Archimon. This advantage reduces the time and cost of post-processing, as well as the overall surface finish of the parts being improved for the customer. From a percentage perspective, it's improved by about 60% compared to regular PA12 and could be further improved by performing ceramic blasting, chemical polishing, or other post-processing treatments. When looking at the values from a RA value perspective, we can see that regular PA12 enabled by Evonik ranges from between 10 and 17 on an RA scale. The PA12FR ranges from a 3 to a 6 on the RA scale. So a dramatic improvement over the typical PA12. The surface roughness, mechanical properties all lead to strong application adoption. Here are two examples of the final parts that have been produced with PA12FR. The first from Bronemek is a relay blade. This is part of the industrial segment and is specifically an electrical component. It has a part volume of about 15 centimeters cubed and is a final end-use part. This part requiring UL V0, UL 94 V0 was previously manufactured using metals on a CNC. Because they had the freedom of additive manufacturing, they were able to consolidate those components from 9 individual parts down to 2 components with multi-jet fusion. And interestingly enough, they were able to have a print-in-place assembly. This reduced the installation time and led to an improved operator experience. Also from Bronemek is a protective shield. This segment is in the railway space and has a part volume of 31 centimeters cubed. This final part also required UL 94 V0 or R26, and was previously manufactured with machining. By switching to printing with HP's PA12FR, we see a 50% cost reduction and a 93% lead time reduction. This also has an improved carbon footprint, reduced environmental impact, and an improved carbon footprint. The last case study from HP is from Markham, which is a hydraulic connector. This hydraulic connector is part of the industrial segment and is a fluid management system. This 30 centimeter cubed part is a final part going into final usage and did require UL94V0. This was previously manufactured using machined stainless steel and had a complex design that includes many relatively thin areas. This fluid optimized part increased performance and is over 20% lighter in weight when compared 3D printing to traditional manufacturing. Again, this part improved the environmental impact by reducing the carbon footprint as well. I'd like to take this time to jump to another poll to ask, what challenges have you faced with traditional FR materials? Hopefully we can get some responses. While this poll is live, I'll go back and talk about one of the things that I mentioned at the very beginning, which was the fact that this is a non-halogenated material. Non-halogenated is important because there are some governments and regulatory agencies that are starting to ban FR additives that have halogenated chemicals. So by avoiding that entirely, we are now compliant with those regulations that are being onboarded, because if you have a halogenated material, when it burns, it could off-gas a toxic smoke, which is something that we obviously don't want to have. All right, we've got some responses here. So it looks like previous challenges include toxicity, limited recyclability, high cost, and performance limitations. So hopefully some of the information I've reviewed previously can help address some of those concerns with the 60% recyclability rate. That's dramatically improved relative to other competitors in the market, and that recyclability rate has a direct impact on cost. As far as performance limitations, obviously this can be designed to the mechanical specifications that have been discussed previously, but you can also expect those isotropic properties that you could have come to know and love from the multi-jet fusion platform. So at this time, I'd like to hand it over to Dan Baker from Endeavor, who's going to talk about some of the applications that they've seen at their service bureau contract manufacturer, Endeavor 3D.
Thanks,
Dan?
Stephen. All right, just a quick background on Endeavor 3D. As Stephen mentioned, we are a contract manufacturer located in the Southeast United States, just outside of Atlanta, Georgia, and Douglasville. We specialize in taking applications from prototype to production, but we also do a number of services around product design, quality assurance, and fulfillment. We are a member of HP's Digital Manufacturing Network, and we focus on a number of industries, primarily automotive, aerospace, healthcare, and industrial manufacturing. So as Stephen mentioned, I'm going to walk you through a few applications. Unfortunately, I'm unable to share the final customer application, but I will walk you through a design project that we ran with the customer once we received the FR material. So it's an automotive customer, and we held a 2-day design workshop where we had an identification or discovery process with a number of materials on HP's platform, but primarily focusing on their new FR material. So what you see on the left is a car door, standard stock, with a number of components. And the first day of our workshop, we identified a number of components within the door that could be replaced using an additively manufactured part. And on the right is the final product. So I'll walk you through just a few of the applications. The primary focus where we landed were on a number of electrical connectors, given the tolerancing of the material, as Stephen mentioned, the new improved surface roughness. We identified a number of 2, 6, and 12 pin connectors, 3D scanned them, reverse engineered, cleaned the CAD up, and then printed them that same day. And here you see them installed on the door panel itself. So there are 10 different connectors within this door panel that were all printed. We used it for testing before kind of moving on to the customer's final part. But it was a very similar application, an electrical connector that was customized and very low volume. So we ultimately landed on using the FR material for that application. That's all I got.
Awesome. Thank you so much. So if anybody has any direct questions and they would like to contact us about the content that was reviewed today, please feel free. This is our contact information. Also, we'd like to open the Q&A. So if you have any questions that would be relevant to the entire audience, please use that Q&A function. We'll jump into that momentarily. Additionally, if you'd like to see these parts in person, they will be at Rapid. We'll have many different parts printed out for people to pick up and see. So please do stop by booth 3201 at Rapid and come see some of the parts in person. This QR code here will allow you to book a one-on-one meeting during the show as well, if anyone is interested in that. All right, and then lastly, we're going to ask one more poll, and I will go to there now. So after this webinar, if you'd like to speak with HP about adopting this material, we can absolutely reach out and set up a one-on-one meeting. If you'd like to learn more about HP 3D printing in general, we can also have a meeting to discuss that. Endeavor has graciously offered to provide FR sample parts. So if you'd also like to, please reach out to them. And then Endeavor also has, in addition to just FR, like Daniel was saying, they have many different offerings from a contract manufacturing perspective. So you can also select that option as well. And then I think we can jump into Q&A, and I'll leave this up on the screen.
All right, if we're ready for Q&A now, I'll go ahead and jump into that. And that concludes the formal part of the presentation. But during the course of the webinar, we did receive some questions in the chat from some of you in the audience, and we'll address them now. If you're unable to stick around until the very end, please remember you can revisit this webinar anytime you wish. So let's get to the questions. One of our users asked if this was going to be available on the 5210 platform.
At this point, it is planned only to be on the 5600 platform, but with HP having a very upgradable path, you can upgrade your 5200 to a 5600 relatively painlessly. So please reach out to your HP representative, reseller, or whoever you're in contact with about your printer to discuss options there.
All right, thank you. And another member of the audience asked if any of the materials meet ECE 118 annexes.
I don't have that data pulled up right in front of me. We can follow up afterwards with that person individually.
Okay, very good. And another member of the audience said that in the previous example, connectors for automotive was just to prove the concept, or was it the resulting cost? Was the resulting cost interesting for the automotive customer? So what were the costs associated with that project?
Yeah, so the example that I showed was just kind of a proof of concept. However, the customer did move forward with a connector application, just different from what I showed. So it's a more customized connector, so a little more complex than what I showed on the screen, and the cost was suitable for them.
Very good. And another member of the audience asked if this material was skin contact approved.
So skin contact testing is undergoing right now, and we should have results in about a month.
All right, so we'll look forward to that. And another member of the audience asked about the possibility of dyeing and vapor polishing parts once they're printed. So what if there's a need to dye and vapor polish parts?
Absolutely. Our blue card only covers raw media blasted parts. However, we do expect to pass those tests under dye and vapor polish. So if you have a specific need, please reach out to your HP representative, whether that's me using the contact information provided, or if you're already working with an application engineer in some way, reach out to them and explain your application, and perhaps that's something we can justify the certification for.
Very good. And I think that concludes the questions that we have received, unless we get any last second questions here. But I think that we are concluded with the question and answer session. And I would just like to thank our presenters here today, Stephen and Daniel. Thank you very much for the presentation. And as the webinar today has shown, the material presented today has a lot of potential for improving your processes and your parts, and it's definitely worth following up on. So thank you very much. You may get more information and contact the presenters directly at the URLs that were provided during the slide presentation. And remember, SME Media and SME can help you keep abreast of all of the latest developments in advanced manufacturing systems and really just about anything that has an effect on the world of manufacturing. You may check out our podcast at advancedmanufacturingnow.com to listen to a wide variety of manufacturing professionals discuss the challenges, opportunities, and factors impacting manufacturing today. And don't forget to keep an eye out for breaking news and coverage of the latest technology and strategies for manufacturing at advancedmanufacturing.org. Thank you for joining us for this SME Media webinar. We hope that you found it useful and informative, and that you will come back and join us for future webinars. Thank you.